Okay. So in the previous two classes we did this lab 1 in which we took a ball of clay and then we changed the mass of the clay and then we measured the diameter of the clay ball. We made it into a sphere and then we measured the diameter, like 5 different trials for the diameter we took, and then took the mean diameter, and then we wanted to plot a graph between diameter in say centimeter on y-axis and mass in say grams on the x-axis. So we don't know what kind of graph we will get, right? We didn't know that time. So then we use the physics which we know to derive some relation between diameter and mass. So when you do an internal assessment, you know, right, 20% of your course weightage is internal assessment. So you have to pick some research question of your own from real life. So it should also be of the form, how does y depend on x? So this is the y depend on x. So as you can see, both are measurable quantities and we know clearly how to measure them using which instrument. This will be measured using vernier caliper, this will be measured using electronic balance. So once you decide this and do the experiment and collect the data, you need to plot it.
Keshav, where is Keshav?
Which?
Keshav Raj Singhal. Has he shifted from SL to HL?
He is shifting again from HL to SL.
He is again shifting?
I'm not sure, but he hasn't come because he has a Spanish exam tomorrow, so he will excuse this week.
Okay. And Arnab Jain, you will attend RMB's class. Because your name is in RMB's class. Because there was a little confusion. Because we want to have even number of boys in each section. One section cannot have more than other. और आपका भी लिस्ट जो है उसमें फिर केशव राज अगर फिर से आ जाता है in your SL, then it's fine. Otherwise, he has to be shifted to RMB's. I am here if you require. मैं थोड़ा सा DHA को रिपोर्ट करके भी आता हूँ. Why these boys are not here?
Sure. So for whatever research question you are doing, you need to find a model or explanation for whatever data you get, whatever graph you get, right? So for that, in this case, what we did, we know that density of clay does not change. If you take less mass or more mass, the density of the clay is going to be a constant. So we use the relation density is mass by volume. So volume of a sphere is 4 by 3 pi r cube. So r is half of diameter. Are you following? If anything is not clear, please ask. So mass by 4 by 3 pi r cube. So when I expand the bracket, d cube by 2 cube is 8. So 4 1 4 2 are 8. So it becomes pi d cube by 6. That 6 came to the numerator. So it's 6m by pi d cube. Since I want to find diameter as a function of mass, I made diameter as the subject. So d cube is 6m by pi and this rho comes here. So finally diameter you will get by taking cube root on both sides. So cube root of this constant term and cube root of mass. So this is the relationship we get from physics. So now we want to check whether it actually explains the data or not, whether the data agrees with this or not, right? So we will plot this function on top of the data points in one same graph. So if the data points lie on the same curve as this, it means our theory is verified or hypothesis is verified. Like this we have to do for your IA or extended essay in physics. Clear? So make a note of this. Can we note it? Diameter equals cube root of 6 by pi rho, and this is mass to the power 1 by 3. So we will plot this function on top of our experimental data now. All of you have installed Logger Pro? Yes?
Can I start this one?
What?
Can I start this one?
Yeah. So this is Logger Pro. Have you all installed Logger Pro in your laptops? You must, because if you want to process the data of your experiment and fit a curve to compare it with your data, you need to have Logger Pro. Okay? So in the last class, you can check out the video. I have explained how to copy paste the data from the Excel into this. So you see here, the mass of clay ball is this column. So I have copy pasted it in Logger Pro here. So let me write it as mass of clay ball in grams. So just double click on the heading and you can write the name as mass of clay ball. Short name you can call it M. Unit is grams. That's it, done. And this is the mean diameter. So if you see here, mean diameter is this column. So let's double click it and call it as mean diameter. Always give the column headings very clearly so that there is no confusion what you need. If you simply leave it as mean diameter, then it's not clear whose mean diameter. So mention clearly mean diameter of clay ball. And then short name is E, unit is centimeter. Then say done. Okay. So now you saw in Logger Pro how the axis titles have automatically appeared here. Now this is the experimental data which we got. Now I also need to plot the error bars for this. So for that, what I will do is, I will, in my spreadsheet I should already have the error bar. So I have the uncertainty column here. So these are error bars or uncertainty I have to add to my data in the Logger Pro graph. So for that, what I will do is, I will click on into this and then I will say data, new manual column, and I will say name is uncertainty diameter of clay ball. Short name will be, don't give it more than 2. Keep the final 2. Weak upper delta D. Units will be again centimeter. Done. So now here I will copy paste those values. The uncertainty diameter values. Control C. Control V. Now what I will do is I have to connect these error bars to the diameter values. Okay? So I click on this cell, right click, column options, let us say
There are options over top right.
very good.
Error bar calculation.
I have to select this. This is what diameter of clay ball, right? For this I have to go to options. I have to go to error bar calculations for this column. And then I have to say use the column of uncertainty diameter of clay ball. Do you understand what I said? What I did? And the color is red. That's okay. So now you see. So this is the error bar. Now you see the meaning of the data has changed. The size of the error bars show you the actual fluctuation in the data. So the precision in our diameter measurement is not so good. So the actual best fit curve could be anywhere passing through this, all through these data points. So you could get a curve like this, but more or less the trend is like this only. Okay? So that's why we can't actually guess what is the relationship unless we derive it theoretically. So if you want to guess the relationship, then you need to linearize this graph, linearize the data. Okay? So that is next step. So first let us fit the function which we already derived. Ruben, what are you doing in your laptop? No, shut it down. You can't use laptops to do other work. Shut it. I'm demonstrating everything on the board, so your attention should be on the board. Shut it. Keep it inside.
So, can this be done on autograph?
Can this be done on?
Autograph.
I haven't used autograph, so I'm not sure how.
And can this be done on graph 4.4?
See, there are so many softwares, whatever you name, I haven't tried those softwares, autograph, all those things. Okay, so now to fit the function which we have derived, what we'll do is click on this function, and then since it's our own original function which we have derived, so you say fit define function, and then you have to type the function value. So open bracket, cube root of 6 by pi rho, right? And the density of clay we also don't know, right? So we will call it as an unknown variable only. So 6 divided by 3.14 into, for density let's call it D or capital D. 6 divided by pi capital T diameter to the power 1 by 3. Okay, then this whole thing is multiplied with m to the power 1 by 3. Just put enough brackets to make sure there is no mistake in the computer's calculation. So let's call this as diameter of clay ball. So now it's in automatic. So since it's in automatic, it will try to fit the curve and find out the diameter value. Density value, density of clay. The suitable density of clay so that it will fit the data points. So now click on try fit. Is it fitting? Yeah. This is the fit. So do OK. So you see. So what is your opinion? Is this fit good or bad? The function which we derived for diameter as a function of mass of the clay, if you try to fit that function, it passes through the data points, almost all the error bars it passes, right? Except the very first data point. So in your internal assessment also you have to write a comment. You have a section called evaluation and analysis. So while analyzing in the analysis section, you will have to comment about this graph. So how will you comment? Ruben? No idea? See, you could say that since the function passes through all the error bars, we can be very confident that this function describes the data correctly and accurately. Then you have to say, however, the data point for the smallest mass and diameter doesn't lie within the function. The function doesn't pass through that data point. So that indicates that there was a lot of, the error was huge, or it must be an outlier. So this data point can be repeated again more carefully. Are you getting it? So if you try to measure this more accurately, you may find that this data point will, next time when you measure it, it may lie on this curve. Okay? So now, in every situation you may not be able to derive a function like this. So suppose you have chosen a research question which is a bit complicated and you don't know how to derive the relationship, and your data points are like this, you don't know what is the relationship. Okay? Then what shall we do? So then we have to linearize the graph. So for that, we could simply try ln of y versus ln of x and see what happens. So that's a trial and error. You have to guess based on this shape. You have to guess maybe cube of this versus root of this, square of this versus cube of this. Like that, you have to do trial and error using some intuition. Are you getting it? You have to guess what combination of x and y you should plot so that you get a straight line. In this case, we know what we should plot. Can you tell me, Harry? What should we plot so that the graph will become a straight line? Yes.
D cube against m.
Very good. So the original relationship was d cube is equal to 6 by pi rho into m. So if you plot d cube on y-axis, m on x-axis, you would get a straight line passing through the origin, and the slope would give you the diameter. Density. Agreed? So let us see whether the slope gives a meaningful density value. It's 2 grams per centimeter cube. Since here it's in centimeter and this is in grams, so this must be the units must be in gram per centimeter cube. So 2 grams per centimeter cube makes sense, right? Seems correct, decent. Okay, so now let's do the linear graph. So just save it and then open new one. So in Excel we have already calculated diameter cube. So that should be on y-axis and mass should be on x-axis. So again copy paste the mass, paste it here, and diameter cube. Now when it joins the data points, make it not do that. So go to graph options, uncheck the connect points, select the point protectors. So now you can see it's almost like a linear thread, right? As expected. Then give the names. Double click the column heading.
Error bar increase for d cube.
Yes, for d cube you have to again calculate the error bar, which we did in the previous class. I'll explain it when I open the spreadsheet. So this is mass of clay ball. So short name, units. So don't be lazy, always do all these basic data entry so that the graph is proper and properly labeled. And this is diameter of clay ball cube d for 3 centimeter. Now here we have a subscript option. Superscript. So now we have mass of clay and diameter of ball cube. Okay. Now we need to add the error bars, right? So if you click on this A, it will auto scale it. Now we need to add the error bars. So click on this data, new manual column. This is uncertainty diameter cube. So again, peak upper delta d cube. This is again centimeter how I calculated the uncertainty in diameter cube in the previous class. See, we will, for any complicated function, we can always go with this simple formula that maximum value of that function minus minimum value of that function divided by 2. So how will you get the maximum value of d cube? It is basically cube of diameter, right? So if you take the maximum value of diameter and then cube it, you will get the maximum value of d cube. Agreed? So maximum value of diameter is whatever is the mean plus the uncertainty. So that's what I have entered in the formula here. See the formula? H7 plus I7. So H7 plus I7, the whole cube. So this formula, if I copy paste in all the cells, it will tell me the maximum possible value of diameter where it has taken the diameter plus the uncertainty of that diameter. Clear? Similarly, minimum diameter cube, how will I find?
So you will subtract the uncertainty.
Very good. So whatever is the mean minus the uncertainty, the whole cube. So I got the minimum diameter cube. Now this gives me the range in the diameter cube. So max minus min will give me the range, divided by 2 will give me the uncertainty. Understood? So in Excel we have this form. Anyway, here it's just 2 cells. So I just subtracted the 2 cells. Here, this minus this one. So now I copy paste the uncertainty. Okay, one more thing. Whenever you use Excel, it will give you like till 10 decimal places. If you put that same thing with all the 10 decimal places in your IA report, you will lose marks. Because it shows that you don't know how to use significant figures, how to round off to the correct, meaningful data. So what do we do here? See, observe how I have rounded off everything. Always, whenever you calculate the uncertainty in any quantity, round it off to one significant figure. Because if you report this uncertainty as points 1, 2, 3, 7, if it's uncertain in point 1 itself, what is the use of reporting the second, third, fourth decimal? Do you get it? So there is no point. So round it off to one significant figure, and by rounding it off to one significant figure, whatever number of decimal places you have here, keep your mean value also rounded off to that decimal place. Since here it is one decimal place, I rounded off the mean values to one decimal place. Got it? So similarly for D cube. Now you are cubing the diameter, and the diameter is known only to 2 significant figures. So cube also cannot be known to more than 2 significant figures, technically. So ideally I should round off everything to 2 significant figures. So it will just be a whole number. But since I am just plotting the error bars, I am not doing that. Okay? But at least I am just rounding it off to 2 decimals. So it's okay. And this is max and min, right? So whatever numbers you use for calculation purpose, you can keep extra decimal places in them to retain the accuracy. But the final result, the mean diameter cube, you see how I rounded it off. So when I do max minus min by 2, again the uncertainty it would have given me to many decimal places. See. It would have given me something like this. So I should not leave it like this in my final table. So I should round it off to one significant figure. So it becomes like this. Whole numbers. So if the uncertainty in diameter cube itself is in whole numbers, what's the point in reporting diameter cube to 1 decimal? It's meaningless, right? So you should round this off also to the same number of decimal places as the uncertainty. So I should actually round it off to 0 decimal place. Like this. So now let me copy paste this. Oh wait, here I should. So once suppose you have entered the value wrong, you can right click and do clear cells. So this is the actual diameter cube. the uncertainty diameter. Now click on right click on this, go to column, right click on diameter, click column options. Diameter of clay wall cube. Go to options, error bar calculations, use column, uncertainty diameter cube. Done. So now you got the linear data with the error bars. Ruben, sit straight. So now we need to fit the linear function. So go to f of x, to fit, and select. Now our expectation is actually proportional. So let's select the proportional itself. So AN, automatic, and try fit. Okay. So that's it. So when you give your IA report, you just take a screenshot of this graph. Save it. This is clay ball. So you see it tells you the slope value with the uncertainty slope also. Now your IB requirements is, Ruben, please sit straight. Your IB requirements to get full marks for data processing after linearizing your function and getting the relation. Okay. You also need to find the uncertainty slope using max and min slope method. So manually you have to draw the maximum slope also, which can pass through all the error bars like this, and a minimum slope also, which can pass through all the error bars like this, and then find the value of the slope. Now using slope, what can we calculate in this formula, in this experiment? Using slope value,
So density.
density of what?
Density of the clay ball.
Excellent. So you can find density of clay ball using the slope value. So if you know the uncertainty in slope, you can find the density also with the uncertainty in density. So that becomes a proper experimental result. So you report that you by this experiment, using this data, we verified the relationship between diameter and mass of the clay ball, and we also measured the density of the clay as x plus or minus delta x. So that's the scientific way of reporting a result with proper uncertainty. So you will get practically full marks, 22 and 24 you will get if you do all this. Simple, right? So just choose any new research question of your own, do the same process, you will get it. So now let me demonstrate how to do for the max slope and min slope also.
Gyaneshwaran, do we always report the size of the error bars differently for each part, or the uncertainties, if it is analog still so?
Yes sir, I will tell you. Actually, it depends on the data we get. So for example here, when we measure it, the least count of the instrument should be reported on top. So suppose when I take 5 trials, if all of them, and if I find max minus min of those 5 trials and find the uncertainty, if this is less than this least count, so it can happen. Suppose I am measuring a steel ball using a screw gauge, it may happen that all 5 trials the same value I get. So then this uncertainty will be 0. In that case, I will report the final uncertainty as this least count of instruments. But in more real life situations, what happens is the random error in the measurement will be too high compared to the least count of the instrument. So the max minus min by 2 will be more. This uncertainty will be more than the least count. So then we will take this. And if it's the random variation, it will vary for each measurement.
This is a very important point.
Yes. So always we report the bigger uncertainty,
Bigger values.
whether it's the instrument uncertainty or the measurement uncertainty.
So calculation is always required for the uncertainty. Don't just rely on the least count straight away.
Yes.
That is regarded as a last minute result, but it will not be too scientific.
Yes. And in graphs, when we draw the error bars, we only plot the error bars of the y-axis, the dependent variable. Because the dependent variable, it is expected that we choose it. It's in our control, right? We choose to vary the independent variable, so it's in our control. So it's expected that you obviously measure it to a sufficient accuracy. Okay? So now to draw the max slope and min slope, what you do is, again click on function and just have a look. If you again treat it as proportional, we will be able to, you can still plot the max slope and min slope. So let's do that. So now go to manual and then do OK. So I got a manual fit. Now what I do is I click on this slope value and the previous slope was 0.91. So now this new slope I will write it as 1.2 and see what happens. It went too high. So 1.1, that's also a bit too high. So 1.05, that's all. I wanted to pass through this last error bar also. So 1.04, 1.02. I think this is fine, right? Okay. So then what you can do is right click, curve with options, change the color, go to appearance, change it to red. Okay, so we'll continue in the next class how to do the min slope. So similarly I have to do for min slope also. I think we'll wrap it up in this. Just as I did for max slope, again do one more of this and then choose the slope value which is lower than the min slope and you get the min slope.
Please go to ERP and ask them to install.
You need to have Logger Pro, Tracker, Audacity,
all these.
all these.
The corner